everybody. We're going to be working today in our Math Masters. This is an activity book the page is going to be attached for you. We're going to be talking about going on a treasure hunt. So we are going to talk about how sometimes we can do things with volume and how it affects the things around us. Okay, so this lesson is not in your math workbook yet. There are bits and pieces that we will do in the workbook, but this first section is not. So pay attention to the screen, take notes if you can, right? It says a treasure hunt. A fifth grade class read an adventure story. In the story, an explorer named Miriam traveled to South America in search of a lost treasure. Traps had been set to guard the treasure. Miriam fell through a trapdoor into a 9-foot rectangular room that measured 4 feet wide by 6 feet long. So you can see that picture right here. 9 by 4 by 6. So this is the room that she's in. Okay. Suddenly, the room began to fill with water. It stopped when the water was 3 feet deep. Miriam sighed with relief, but her relief didn't last long. The 2 4-foot wide walls in the room began to move, making the room even smaller and causing the water level to rise. Every 10 minutes, the walls were 1 foot closer together. So, think about it. I'm going to show you my little Pepsi bottle here. I'm drinking a little Pepsi. Hold on just a second. Okay, so this is my little pop bottle that you see here. And you can see where the water stops, right? Where the pop stops. What happens when I squeeze the bottle together? What happens to that level of water? Or pop? This is where it starts. Right here. Now I'm going to squeeze it. Look what happened to that level of the soda in the bottle. It went higher. The reason why it went higher is because the volume of the bottle was changing. All of the extra air that's up here was kind of escaping a little bit, and so the level of the water was rising. It had less room to spread out, right? So that's kind of what's happening to the room. So it says, to the right is a picture of what the room looked like after 10 minutes, when the 4-foot wide walls had moved 1 foot closer together. Okay, so this is where it begins to fill with water. I see that the volume of my water is 3 foot by 6 foot by 4 foot. Okay, so 3 times 6 times 4. What is 3 times 6 times 4? Okay, I'm going to get my little pen tool over here. Maybe. 3 times 6 equals 18. And if I multiply that by 4, okay, let's see. 4 times 8 is 32. Here are my 3. 4 times 1 is 4, plus 3 is 7. So my water is 72. Oops. 72. Imagine that, the 2 guys, sorry. 2 cubic feet. This is how much water is in my container. All right? Now look what happens. 5 foot by 4 foot by something. Did the amount of water change? No. Did they pour more water in? No. It says very clearly in my story that the water stopped moving. And I'm going to highlight that for you so you see it. Let me put this out of the way. Let me go back to this little highlighter moment. It said that the water stopped. Hold on. Right there. It said that it stopped. That means that they didn't put more water in. So did the amount of volume change? We said it was 72 cubic feet. Did it change? No. So what we have to do now is we have to figure out this water is 72 cubic feet. 4 times 5 times what equals 72. 4 times 5 times blank. That's why I hate this little thingy. It's not working for me. All right, let me go back to my pen. 4 times 5 times something has to equal 72. What number would go in that blank? Okay, so what we're going to do now is we're going to actually do the math that goes along with this. I'm going to scroll down a little bit. 4 times 5 is 20. Right? So now I need to do 72 divided by 20. 72 divided by 20 is 3. Okay? And then I have 12 left over. Now, we've shown you a little bit of how to continue with the decimal, so I'm going to show you now with the number to make it into a decimal. Remember, you're going to put a decimal here. You're going to bring a 0 and bring it on down. 20 goes into 126 times. So your final answer, the height of that water, is 3.6 feet. It was 3, and now it's 3.6. Now, if you said 3.5, close enough. Remember, it is kind of a little bit of an estimate. It says what is an approximate height. That means what is like an estimated height. Okay, there we go. The only way out of the room is through that trap door. Okay. About how much time do you think will pass before the water lifts Miriam up to the trap door? So right now, we learned that in 10 minutes, the water grew about a half foot. So let's write this down. We're going to make a chart. Okay? So we know at 0 minutes, our box, let me figure it out here, is 6 feet by 4 feet by 3 feet. Remember, this is my height of the water. That's the height of the water, right? After 10 minutes, it was 5 feet by 4 feet by 3.5 feet. Remember, as you multiply across, it's always going to equal 72. Right? After 20 minutes, we have 4 feet by 4 feet by something equals 72. 4 times 4 times what equals 72? If you did the math, it should be about 4.5. It's getting higher faster. What happens at 30 minutes? That line was wonky. Let's try it again. What happens at 30 minutes? Here we go. 3 times 4 times what equals 72? Do the math. 3 times 4 times what equals 72? I know that 3 times 4 is 12 times 6 equals 72. Ooh, it is getting higher faster. Let's try one more. After 40 minutes, we have 2 feet by 4 feet times something equals 72. 2 times 4 times what equals 72? 2 times 4 is 8. And then if I multiply that by 9, it would be 72. That means after 40 minutes, my water would be 9 feet tall. That means that if I were stuck in this trap door, I would be stuck there for 40 minutes before I could get out. 40 minutes. That should have been your final answer. Now, that is how you answer this kind of question. Now, notice it says, explain how you use representations to help you solve the problem. So this is where you're going to use those math words. I looked at each time measure. I measured each of the walls. I figured out what it would be. This is where you need to use your math terms. Okay? I want you to take a moment and write an answer. Explain to me, with this work, how we use this to show how long it would take. I should have at least 3 sentences or you don't get the points. All right. Now we're going to look in your math workbook. So this technically should have been a little bit at first. It's kind of the same idea. About what you think would happen when we squeeze the juice box. We're not going to do this workbook page because basically it's what I did with my drink. Okay, remember, it's just like if I take my drink and I squeeze it, the amount goes up, right? Same thing with the juice box. If you've ever, telling you, Lincoln already knows this one. If you ever have a Capri Sun or if you ever have one of those apple boxes and you squeeze it, once the straw's in it, it squirts across the room because the amount of fluid wants to get up because the volume in the bottle gets smaller, right? So that's basically what happens. It's talking through the process about the juice bottle versus what we did with my drink at the beginning of the video. We are not going to do this page. You are going to move on to the next little part of your activity. I hope that you had a great day. I hope that this